Welcome to the shop. I'm continuing to make parts for NQALHA Production Run 4. There's 750 parts to make, and I'm getting close to the end, so better get going. In today's video, I'm going to be leaving out some of the stuff that I showed in previous videos. The tools are loaded, the machine is set up, the zeros have been indicated with the Heimer indicator and the Tormach electronic tool setter. Everything is in place and ready to go. I created an optimized gang tool path for milling 2 parts first operation and 2 parts second operation, and I did that off camera. It's maddening and frustrating to do this, and for anybody that watched my previous videos before this one, you got a little taste of how annoying it can be to make a change, see if it works, find out it doesn't work, go dick with it, go dick with it, go dick with it. So anybody wants to watch me fumble around and flail around and make mistakes, well, it's in other videos. I do have a comment about BobCAD-CAM software. It's inexpensive software. It's all that I can afford because toolpath software, the really top-end stuff can be just horrendously expensive. I mean, way, way, way beyond what I could ever afford for the kind of work I do and the budget that I have. But BobCAD, it unfortunately is full of bugs. And since I spent most of my professional career writing software, I kind of understand a little bit about how these kind of bugs arise. So I'm just going to take a moment to talk about software a little bit. When software is working correctly, you can do a kind of an incremental refinement process where you start out and I'm using the example of CAD toolpath. You can create the first piece of toolpath, get it perfected, move on to the second one, move on to the third one, move on to the fourth one, and just incrementally continue building, adding and adding and adding until you're finished. What happens with BobCAD is that by the time you get to the 15th step and make a change, it just decides, oh, I'm going to change the 3rd and 4th step. Just who knows why. So that's one of its problems. Another one of its problems that I've found is very common in software, that if you start at the beginning of a project with a blank document, do step 1 perfectly, step 2 perfectly, step 3 perfectly, and on and on and on, everything is fine. If you go and change things, if you try to move step 3 to step 2, you try to change the geometry, change the tool, change the depth, change any change really, that's when the bugs start popping up, is when you start editing things. And that's in BobCAD, anytime you do a cut and paste, or change a geometry, especially in the drilling operation. The drilling operation seems way worse than the milling operation. And also machining order. When doing a complex multiple station toolpath like this, machining order is super important. And sometimes it just, you make a change somewhere. You make a change, I don't know, something in the roughing toolpath. And all of a sudden, it'll decide, oh, I need to change the order of the operations. So in BobCAD, it's, make a change on step 15, then go check every single step by hand, then go out and run it, find out it doesn't run quite right, make a change, check every single step by hand, and I pretty much spent the whole morning dicking with this. Probably 3 hours. And, well, you might ask, well, why do you bother? Well, first of all, it's just a challenge. And this whole project is all about the adventure. And there's kind of a challenge to try to figure out, well, how good can I make the toolpath? But the more important reason is the part that I'm making here is the main drive rollers. Every NQALHA gets 8 drive rollers, which means I need to make 80 of these little guys. And so taking a little time in the beginning to optimize the tool path, do the 2-up gang, and try to get as much time out of it kind of makes sense. So tool path has been tested. I can run it at full speed. First operation is milling and drilling the blank. Second operation is cutting the rough outside perimeter. And then the third operation is actually something that I haven't shown before in this series, which is to mount the Tormach RapidTurn, which is a kind of a, very minimal, limited CNC lathe attachment thing that mounts on the Tormach mill. And even though it's barely a CNC lathe and really doesn't work that well at all, works well enough to do this work. And that's where I cut the O-ring groove, which needs to be pretty darn precise to make sure that the rollers are all the same diameter and that they all run true. So I'm going to go ahead and show the first and second operation in a 2-up gang. Starting with the Lakeshore carbide roughing cutter, starting on work offset 3, which is the left vise. This is the aluminum shredder roughing cutter, and this one is running at 50 inches per minute, doing 2 passes to cut through a little bit over a 1/4 inch, 0.26 of material. Basically what I'm doing here is knocking off the square edges. The turning operation will finish the outside of the roller, both the O-ring groove and the outside shape. So got to get that tool high enough to avoid hitting that mounting screw. Here I'm going at 60 inches per minute, doing a spiral roughing pass, and once again doing it in 2 passes. As I was optimizing, I thought, well, what if I slow down the feed and do it all in 1 pass? And so I tried programming a single pass at 30 inches per minute, and it shattered like crazy. No spindle problem, but the Tormach it can't handle heavy cuts, or else it starts shattering. The aluminum shredder is a great roughing tool because it produces really, really fine chips that are very easy to clear. Of course, in this operation, since I'm not cutting slots or pockets, I don't really care about chip clearance, chip evacuation, but I still like using the aluminum shredder. It's just a great roughing cutter. 5,140 RPM, which is the full speed of the machine. And I'm roughing out the shape. Pushing the machine, I'm looking at which you can't see on the video, I'm looking at the spindle horsepower meter, and it's still well within the green. There's a chance maybe I could bump up the feed a tiny bit, but I'm just gonna leave it like it is. So now, gonna drill some holes. The holes around the rim are purely decorative. It's one of my design elements. I just like geometric arrays of holes. I use it in my artwork. I use it on the NQALHA arms. On the arms, it actually helps to reduce the weight of the head. On the rollers, hey, it might reduce the weight a little bit, but mostly it just makes them look cool. So I consider these to be mostly a design element. The drill is going at 2,500 RPM, 10 inches per minute, using a fast peck cycle. This is 1/64 under 3/8 because the center hole, which was just drilled, is a fairly critical hole. That goes on the main axle, and the concentricity of that hole and the outside O-ring groove kind of determines how the glass piece is going to rotate. So I take the extra step, take the extra few seconds of drilling a 64th undersize and then reaming the hole to try to get a nice, accurate 3/8 hole. Got a tiny little bit of buildup on the cutter, not much. I try to optimize my peck cycles, feeds and speeds to make short, thick, broken chips as opposed to long, stringy, continuous chips. Reaming at 250 RPM, 5 inches per minute, with a 3/8 straight flute reamer. And then after the ream, I do the last operation, which is the finish operation using a Lakeshore carbide 1/2-inch 3-flute end mill. And the reason that I do that is that the drilling operation, sometimes the chips that are being flung away from the hole can actually ding up the surface of the part a little bit. And so by finishing after the drill operation, I get a tiny bit nicer surface finish, which is just, it's one of those little details. I have to do the tool change anyway. Doesn't really cost anything to modify the sequence in that way, but it does make the part come out a little cleaner, and it is a machine being sold to artists, and I consider myself an artist, and surface finish is important. Having the parts look nice is important. So I'm moving to the unload position. I've already made a couple of parts, so I can show on camera what it looks like after it's been deburred. So that is the second operation part, got no O-ring groove. And I'm going to go ahead and run all the rest of the batch of 80. And then after that's done, take the vise off, put on the RapidTurn. I'm going to go through the entire detailed setup process of mounting, configuring, and setting up the RapidTurn, just in case anybody's interested, because I've never showed that before. So I got a lot of work to do. I'm going to get going. I might not finish this today, who knows. But anyway, see you later. Hi, welcome back. Boy, it's been an exciting day, and not exciting in a good way. We had a power failure. I'm running on a backup generator, and there's a fire in the area. So, boy, I just hope I'm able to make it through, but I'm not going to just sit around and wait. I'm going to continue working and see what happens. The first and second operations are complete. I need 80 parts, but I made 86 just to have a few extras because sometimes things go wrong, and I want to make sure I have enough. I'm going to be doing the switch over now to the Tormach RapidTurn, and I may show the entire process or speed it up or edit or something, but anyway, here goes. The first thing I'm going to do is remove the left vise, The right vise can stay in place. But I may remove it anyway, just because it's nice to periodically look at the machine table and see how rusty it got. The coolant claims, that's not bad at all, the coolant claims to be a rust preventative, but hey, you know, there's claims and there's reality. So I'll go ahead and just take them both off. After last year's power disruptions, I got a really nice backup generator, and I'm very happy that I did. And in case anybody is wondering, of course I installed it myself. One of the nice things about having a variety of skills, I'm not dependent on others to get things done. Actually, the table doesn't look so, first thing I'm going to do, hit it with a little WD-40 and a Scotch-Brite. And yeah, it's cleaning up very nicely. The little rust and discoloration is very minor. Actually, you know what I probably should do if I wasn't so lazy is just to periodically take the vices off and check for rust and clean everything. So now the table is pretty darn clean. I'm gonna take a stone. This is a reasonably flat stone. It's not one of those very expensive machinists' precision ground stones, but hey, it's what I have. And it will, if there's any little, tiny little bits that are sticking up, it'll kind of knock them off. So wipe very carefully. And there we have it. So here's the rapid turn. Make sure it's, yeah. It's got a motor in the back and 5C collet. And it's got some locating pins on the bottom that kind of make it somewhat convenient to do the setup. It does have one ever so slightly insane design where it's got slots here, here, and here for hold down screws. Well, this one is like completely inaccessible. This one is, yeah, maybe accessible with a little bit of pain. This is the only one that's actually really accessible. And for the kind of work I do, I only use this one. And I don't know. You gotta wonder sometimes about why things are designed the way they're designed. So now that I've wiped the bottom, I'm gonna be, oh, and it's heavy too. Good thing I'm big. So there we have it, in place. Now, it's got two cables coming out of it. One of them, I believe, is some sort of a sensing cable, and that goes into the accessory port. The accessory port right here is a 4-pin connector that is where the electronic tool setter hooks up, but for lathe work you don't use the tool setter and you gotta plug this guy in. So I'm gonna make sure there's no chips in the connector. Machine shop work and electronics, often a dangerous combination. So this design is full of compromises, but one of the compromises that they made is, let me move the camera here. Kind of hard working in a shop with all these tripods and cameras. One of the compromises that they made on this design is that there's a single VFD in the control cabinet, variable frequency drive, that normally drives the spindle motor. Well, when the rapid turn is installed, you need to disconnect the spindle motor and connect the rapid turn using the connector here. So hope we get this on camera. I mean, it's not that interesting, it's just a connector. So here goes the spindle drive. then and now I've connected the RapidTurn to the junction box up here, so now it's connected to the VFD. You get the cable out of the way a little bit here. Okay, so the next thing that I need to do, and yes, there are many, many steps to this. Got to go over to the controller, switch to RapidTurn. The same control software operates the mill and the RapidTurn. And for those that don't know this, CNC lathe coordinates are not the same as CNC mill coordinates. And when I first started using them, I thought, wow, this is weird. Why do they do it that way? And I assume that, you know, at one time it made sense to somebody, and it is the standard, and there's really nothing I can do about it other than just learn to live with it. But in the normal operation of the mill, X direction is left and right, Y is in and out, and Z is up and down. In the lathe world, X is the diameter of the part, which on the Tormach translates into the head moving up and down, and Z is the distance from the collet down the piece, which is effectively the x-axis, and then the center height of the tool actually mounts from the top, and as opposed to mounting from the front, as you would imagine in a normal manual lathe, the tool actually comes in from the top and the spindle rotates the opposite direction from the direction you would expect for a manual lathe. So the height of the center line of the tool is set using the y-axis. Very confusing, a lot to remember, many, many, many opportunities to make mistakes. The Tormach RapidTurn is a very, very limited light-duty machine. It works, but to be perfectly honest, it barely works. And fortunately, the work that I need to do, it's adequate, but it's not that good for very many things. It has a tool holder, kind of looks like a regular lathe tool holder, except it's tiny. This is like the tiniest little quick disconnect tool holder you can imagine, and it fits onto this big steel bracket that goes thusly onto the head, onto the spindle. So see if I can. Oh, another thing, another glorious design decision that Tormach made. Some of the fasteners are imperial, some are metric, some are mixed. Sometimes a piece will have some metric and some imperial, just to make the world a little bit more difficult. So, tightening that guy down. Going to be using a parting tool, a carbide insert. Let's see if we can get that on the camera here. Okay, where was I after being interrupted? So this is an insert tool, a carbide insert turning tool in a tiny, tiny little holder. Everything about this thing is tiny, and it fits thusly. But first, I am going to reference the z-axis. And once again, the Tormach is a stepper motor machine. It does not have encoders. Reference the y-axis and reference the x-axis. The machine does not have linear scales to measure the position of the various axes. It has open loop stepper motors and ball screws of, I hope, good quality, but who knows what quality. When the machine is first turned on, it doesn't know where zero is, and so you need to perform a referencing operation, and the referencing operation slowly moves each axis to the limit switch, which is a mechanical limit switch, not a super precise measurement device that can measure within microns, just a mechanical switch with a little roller that conceivably could get chips on it. And so you really can't trust the referencing for anything other than probably emergency limit switches and that kind of thing. So the last little bit is also ever so slightly annoying, and that is, let me get Mr. Camera over here. I'm now using the VFD, the same VFD that normally runs the spindle motor. I'm now using that VFD for the RapidTurn. Well, it turns out the two motors have different operating parameters. So it's necessary to remove the programming plug, probably some sort of data device, and of course it isn't a standard USB stick. It's some kind of, goofy-ass proprietary thing. And so you stick that in, and now we're ready to go. The RapidTurn also has another way to get in trouble. Evidently, somebody thought it was a great idea to have a little locking lever here, so you can use it as a kind of a somewhat crude indexing head with 15-degree increments. So if you put the little locking thing, it'll lock it at a variety of different 15-degree increments, and there's a little dial over here that shows where it is. And of course, the gotcha is if you turn it on and forget that it's locked, well, the motor's going to slip and it's going to mess up your pulley and mess up your belt. And just another handy-dandy way to have pain and failure with the Tormach. I'm going to use the one and only one easily accessible hold down screw. And go into the lathe room and grab a collet. Of course, the little locking thing does kind of make it easy to, it's not all pain and failure. It does make it easier to tighten down the collet. So now, let me figure out what camera to use here. Doing this work is hard enough just to do, and then on top of that, trying to manage a 4-camera video shoot. Boy, I must love pain and difficulty. So I'm going to move the z-axis I'm going to move the x-axis there is no way, at least no way using tools that I have, to set the part zeros easily. The Heimer doesn't work, the electronic tool setter doesn't work, so I kind of am reduced down here to the most manual methods. So and of course I haven't used the RapidTurn for a very long time. And that makes it even more difficult to remember. So the way that I need to do it to start the spindle, you gotta enter an RPM. And then using the Tormach job shuttle control, the USB job wheel, keeping in mind that this is a very lightweight machine, and I gotta take the smallest of cuts. Okay, so now I'm barely kissing the surface. And now I'm manually feeding in the Z-axis. And I'm going to take the micrometer and measure the cut that I just made and tell the system what that measurement is. $9,573. Let me measure that one again. 9,571. So 0.571 has now been entered as the X diameter. So I've got a little holding fixture here. Let me show that guy. And the holding fixture, get the test piece out of the collet, put the holding fixture into the collet. So Z0, which of course in CNC lathe coordinate, Z is this way. Z0 is the face of the little holding fixture. Of course, everything is difficult. Nothing is easy about this process. So I'm going to just move the Z-axis in 10th increments until the paper gets stuck. And I'm also going to realize that I probably made a bit of a mistake here. I'm not sure how serious the mistake is, but I may have to start over again, because it looks like the alignment of the I just kind of eyeballed, I didn't indicate. Hope A-bomb isn't watching. Let me go get the indicator. Okay, I'm gonna do it right. Get the indicator in place. No half-ass for me. Whole ass or no ass. I'm going to call that good enough. I'm not going to dick around with this all day. So now, get my piece of paper back. Every time I use this thing, I think, wow, I really wish I had a real CNC lathe. Okay, so the paper is barely dragging, and paper is 3/1000 thick, so Y, or actually Z, excuse me, Z is now 0. Gotta remember which direction is which, and of course, since I changed things, I need to revisit X. So here's one of my parts, one of my second operation parts. The little holding fixture was made on the lathe, and it's got a shoulder screw that was pressed into a reamed hole, drilled concentric with the diameter that was turned. So the part goes on, thick washer goes on, and a nut to hold it in place. And hopefully, with any luck, things will go well. I will be using a tiny, tiny bit of flood coolant, just barely on. Just barely a drizzle. And I have what I believe is a known trusted tool path. Now, since I don't have CAM software that will do lathe work, the tool path for this turning operation was completely constructed manually, 100% manual. And it's worked in the past. It does produce good parts, but boy, is it ever a pain in the ass to set up. So let me get a couple of these cameras out of the way. Don't need all these guys for the next steps. Yes, it's always a tiny bit nervous when running the turning for the first time. But anyway, let's give it a go. See if it works. Could be exciting. Tormach RapidTurn. And I think everything's ready. And gonna have the finger on the stop button, and I'm gonna stop talking. Now that is completely wrong. So, wanna know why it's wrong? The safe Z position, the first thing that the rapid turn does when it starts is goes to the safe Z position, and the safe Z position is really dependent on, well, where did I put that thing? And probably the time before this, I had the right vise in place and I had the rapid turn further to the left. So I'm now going to set the safe Z position. And spindle is rotating. Coolant is on. Got my finger on the stop button, and I'm going to stop talking while this is going on, so. That looks sane. The operation here, I'm going to be making a chamfer going up, going across to clean up the flat surface, then down to form an O-ring groove, then up and then back and then down again to widen the O-ring groove, because the O-ring groove is a bit larger than the width of that insert, then back up to diameter, back to the left, and then continue with the chamfer on the left. It's not working correctly. Well, So many ways to make a mistake here. As near as I can tell, I'm gonna have to do everything over again. I have a work offset and tool offset problem. Been a long time since I've done this, so I don't remember what's going on. So many things to remember, and of course I didn't write any of this down. 9538. 9537. Yep, that's yet another thing to remember. And of course, I haven't used this thing for a very long time, and it's hard to remember all of the little details. Did I mention that I really wish I had a real CNC lathe? This is not a process that I enjoy doing frequently, and it's kind of why I left these drive rollers until the end, because setting this thing up is a royal pain, a royal and annoying pain. So there we go, checking. I'm also going to be turning the main arm axle using the RapidTurn, so you kind of want to get both of them done in the same setup, because like I said, this setup is awful. So what I forgot was that the lathe has a bit different way that it deals with tool offsets. And so in the mill, you're only dealing with one thing. You're dealing with the length from the mounting face to the tip of the cutter, and it's a single thing. On the lathe, there's a whole bunch of different, depending on how your cutting tool is set up, you can define the zero as one edge, the other edge, in the middle, in the bottom. There's like this array of like 12 different or 8 different, I think it's 8 different orientations where you can set the offset for the tooltip, and I didn't have the offset set correctly because I tried setting up the machine before running the G-code, and the G-code set up the tool number, which I totally forgot. Boy, that's looking right. Cutting the chamfer, cleaning up the top. Going to be pecking the groove in the first pass to avoid building up a rat nest of chips. So I'm going to do a little bit of cut. Oh yeah. I'm going to cut and stop and cut and stop. I'm throwing in a chip breaking cycle that isn't really breaking very well. Oh, and then I guess I turned the coolant off for the second half of the operation. So, will you look at that? After all that work, gadzooks. So, I can get it up against a dark background there. There is the O-ring groove with its chamfers. All is well. I'm going to run the batch, 86 parts, and hopefully I don't get evacuated. Hopefully the shop doesn't burn down. What else can go wrong? I mean, this has definitely been an exciting time, and not exciting in the good way. So hopefully maybe you've learned a little bit about how incredibly annoying it is to set up the Tormach RapidTurn if you haven't set it up for a long time and forgot all the secrets. So anyway, I don't know if anybody's going to make it through this video. This has got to be one of the worst ones ever, but for all you who are still watching, thanks for watching. It's been something.